Two disks of equal mass connected by a rod of negligible mass are lying on a smooth horizontal surface. The rod is hit at its midpoint perpendicular to its length. You can see the rod translating with a constant velocity without any rotation. If the hit is at some point other than the midpoint, the disks rotate about an axis through the midpoint of the rod and the midpoint moves along a straight line. The disks in this case are not of equal mass. The hit is perpendicular to the length, imparting a rotation and a translation. The point which moves along a straight line is the point closer to the heavier mass. This point divides the line joining of the mass in the inverse ratio of masses. In the absence of external forces in the horizontal plane, the horizontal momentum of the system does not change, and this is the case here after the hit. The individual masses may have a complicated behavior, but there is a point which moves with a constant velocity after the hit, and this is the center of mass. Mass of the system can be assumed to be located here for the purpose of calculating the momentum of the system. This time the disks are of equal mass and are projected into the air. You can see the midpoint of the rod moving along a parabolic path. In this case, one of the masses is heavier than the other. You can observe the parabolic path of the point closer to the heavier mass. For the purpose of analyzing translational motion of a many-body system, the mass of the system can be assumed to be located at the center of mass. Momentum of the system at any instant is the product of sum of mass of the system and the velocity of the center of mass at that instant. External force in the system can be assumed to act at the center of mass to analyze the translational motion of the system.